Hi everyone, welcome to today's edition of Migrating SQL Server Database to Google Cloud under our Migrating Enterprise Database. For today, we are going to explore creating SQL Server Databases on Compute Engine. But before we get started, let's do an extensive analysis on why we should create an SQL Server, or what are the necessary configurations when we are creating an SQL Server database on Compute Engine. SQL Server on Compute Engine is basically just relocating the server from a local machine, let's say like your on-premise database, to a Compute Engine virtual machine instance. It is often the easiest way to do the migration itself, but may not be the best for a long-term option. When you are creating the Compute Engine virtual machine, you typically start with a bare window image and install all your own SQL Server database into it. But Google Cloud also offers some pre-built SQL Server, which simplify the whole process of creating the virtual machine. It provides an high level of security against attempts to hack your server by providing mechanisms to detect and prevent unauthorized changes to the software and protect keys and certificates. When you use the images provided by Google, it also comes with a shielded virtual machine feature. And under the shielded virtual machine feature, let's talk about some properties of a shielded virtual machine features. The first, which is secure boot. It ensures that only verified software runs. It also uses a digital signature on all components, and it stops boots if component is typically tampered with. Another properties of the shielded virtual machine feature is that it comes with a custom chip called Virtual Trusted Platform Model, or VTPM. Its major work is to protect digital signatures and integrity. Another feature is the integrity monitoring, which compares boot information to a stored database. And it's also a hash value that is stored in the VTPL. The shielded virtual machine feature are available when you configure the virtual machine, and you can enable just the one you want among the one we mentioned. The pricing for Windows and SQL Server license fee is built into the running cost when you use Google Images. This pricing differs based on the SQL Server you choose and how many cores you configure the virtual machine for. You can also add additional disks to store your SQL Server data when creating the virtual machine. You remember that you pay for what you allocate and not what you use. So you can choose SSDs or standard disks, and disks can be between 10 GB to 64 TB, and you can set up snapshot schedule for automated disk backup. You can choose the region you want to save your snapshots, and it is also very good to take your snapshot during off-peak hours. And if you don't want a situation whereby you have to stop your machine when you want to take snapshots, you can go for Windows machine and enable the volume shadow copy service, which safely creates snapshots without needing your machine to be off. You can also configure the virtual machine network interface to provide secure access to the SQL server. Typically, you don't want an external IP address on your database, but you also want to provide a private network for clients to access your server. So you can use the console to configure the machine. You can use the console to configure the machine, but automate its creation using code. That means you can configure the creation of the machine on your cloud console, but when you want to, you can just copy the equivalent command line and automate it on Cloud Shell, or just using Terraform. So for Windows servers, you typically use RDP in order to RDP into the server. And for this, you need to set up a Windows username and password to be able to RDP into those servers. SQL servers on Compute Engine best practices. Let's talk about some best practices that you want to take note when creating an SQL Server database on Compute Engine. The first is to use Windows Server Advanced Firewalls. So you should use the operating system default settings, as they are typically optimized to run on Google Network. Also, follow the Microsoft guideline for antivirus software. You should also use separate SSD persistent disks for your log and data files. So if in the case whereby the log drive is full, the data can still be written to your database. Create a new SQL Server instance with one or more local SSD to store the temp DB and the Windows programming files. And it is very good to have a plan for backups and perform backups regularly. You should also install the cloud monitoring agent for Microsoft Windows. Typically, if you want to save time when building your image, you can just go on the cloud marketplace and search for SQL, and you can find pre-configured virtual machine on both Windows and Linux that you can use for your SQL Server. And that way you reduce the time spent on building your image. You can configure SQL Server to also have an always-on availability groups for high availability. This typically requires an Active Directory domain controller. You also need one SQL Server in the main, that is, one of your SQL Server would run in a failover cluster managed service. You also typically need to have one or more replicated server. In this case, each server has its own data replicated from the main. And if the main fails, it can automatically switch to the failover. So this architecture is quite expensive as it uses an enterprise edition of SQL Server. So you may want to consider the image you'd need efficiently and don't just build on guess when you are using an SQL Server always on availability group. If you also want high availability, you can also configure SQL Server failover cluster instances. This typically use Microsoft Storage Spaces Direct, which we call the S2D, to create software-defined virtual SAN for persistent disks attached to each SQL server. And when you want to do this, you typically set up a failover cluster, that is, one SQL server is active, and if the active node fails, it can switch to the failover. And you'll also use an internal load balancer to route requests to active server. Feel free to check out the documentation on how you can create a SQL server using the various illustrations that I mentioned here to have a better overview or to see tutorials on how to create this server. So on this note, let's get into our lab. The first thing we typically do, as always, we start our lab. So, am I a robot? So let's wait for it to provision our lab information. Then we open in an incognito window, copy the password. The username gets copied for us automatically. Paste the password here. Yeah. So the next thing we want to do is activate our Cloud Shell. And after my Cloud Shell is getting activated, I'm also going to open my Cloud Editor because I know how to use it for this lab. So it may take a while, but I just wanted to do that while it's running. Let me duplicate this so I can use one for my terminal. Okay. I'd leave this to keep initializing my Cloud Editor while I face the terminal from here. Okay. So we've completed this part. So for task 1, we want to create client and server virtual machine. And this is our project ID. We would need it along the lab. The first thing we want to do is we want to clone a GitHub repository that has the completed versions of the previous lab that we've done. So if you want to really enjoy this, it is quite very good to follow up with all the previous lab that we've done. And we are just going to build on the code that we used in our previous lab, because in this lab we'll be using Terraform to automate this creation of SQL Server Database on Compute Engine. So I'll clone the repository. And while my repository is cloning, I'm just going to wait for it. You can take a look at my Cloud Editor and see if it's done. Not yet done. So let's wait for our repository to get cloned. Yeah, so our repository has been successfully cloned. Then I want to cd into the path on that repository. So this is the part that I'm interested in under training data analysis, courses, database migration, then Terraform SQL Server on Google Compute Engine, which is the part I want to more concerned about. Yeah, so our editor is fine now, and we can open our editor in the new window. I can close this out as I have my terminal here already. So close this out, just leave. Here's my editor, here's my terminal. So let's wait for my editor to just to expand this, and you can see this is the training data, then courses, then database migration. Under database migration, we're interested in Terraform, create we're interested in Terraform, create SQL Server on GC, which is Google Compute Engine, and these are the files that are here already for us from the previous lab. So what I'm just going to do is I can list all my files on my Cloud Shell, and let's see. So since I'm in this directory also, when I list, and here are all the files that you can see here. Okay, so let's keep going. So the next thing we want to do is we want to open the terraform.tf verse and make sure and change the project ID to match the project ID that we are currently using, since it is just templated there. So I'll go to my Cloud Share on the terraform.tf verse here. I'm just going to replace it with my project ID for this lab, so it saves automatically, which is fine. But the next thing I want to do is I want to create a new file named vmsql.windows.tf, and I can create the files I can create it manually on the cloud editor, and I can create it from my Cloud Shell with the touch command. I'm just going to use the touch command. So touch, then the name of the file, so it's get created name of make sure that you seed it into the directory that you want the file to get created while doing this. Okay, so and now you can see the file we created is virtual machine SQL Server Windows.tf. And then the next thing I want to do is paste all this code here into it. And what this code typically does is that it is the configuration for our SQL Server machine in a private network that we are going to use. So this is the SQL Server, putting it in a private network. Then we create some other networks that we can use to connect to this. So this is for this. So the next thing we want to do is we want to create a file named this, and this file would house the Windows machine in the public network that we can use to administer the SQL Server. Take note that we are creating our SQL Server in a private instance, and we create a Windows machine in the public instance that we can use to administer our SQL Server. So this one, I'm going to create it manually from the cloud editor. You can right click on this, on the folder, and you create a new file, then the name of the file to get created, and this is it. So let's paste the code we want to do for our Windows machine, the configurations. So it's typically a Compute Engine instance, and these are all the configurations we want it to use. This is an SQL server, and these are all the configurations we want it to use. So creating an SQL server on a Compute Engine instance. So as you can see, these are the configurations for the SQL server instance that we are going to create, and it's typically empty. There's no database on it at the moment, but this is the server that we are going to use, and we are using an image of Windows, which we are using the Windows SQL Cloud. So these are the necessary configurations, and if you look at this one, we're also using the same image. So I'm just going to paste this here. It's going to save automatically, like you all know, and Other machine we're also going to create is a Linux client that we can use to connect to the SQL server. We are going to name this the virtual machine SQL client.tf. So for this, I'll use the cloud shell so that we can save some time. Just with the touch command, then it's get created for us automatically. So let's see. This is it. When we open it here, here's the file. Then we want to paste the information here. So this is a Linux client, like I explained, and it is an Ubuntu operating system that is installed on it for Linux. Now we'll just use this to connect to the SQL server. So paste this here. So this can serve as maybe like the external client that is trying to connect to our SQL server. And we said we are going to make sure we are going to create this without an external IP address, just being a private network. Then the SQL client or the third-party client I want to talk to our server would talk to this, and from this it can administer the SQL server. That's the architecture we are doing, and everything has been saved as expected. So the next thing we want to do is we'll open the VPC firewall rule.private TF file. So if you follow the previous lab, we've created this firewall rules. We have this firewall rules file already, but since we want to have some firewall rules for our SQL server that we're just creating, then we have to put the firewall rules. We have to set the firewall rules here, and that is why we're setting the firewall rules here. So we'd go to firewall rules.private, specified here, firewall rules private.tf. Then just on the next line, paste the firewall rule for our public subnetwork, which is allowing SQL TCP protocol here. So which is fine. The next thing we want to do is, after we've done all this, then we can initialize our Terraform, then plan the resources we want to create. Thereafter we can now Terraform apply auto approve. So typically from your Cloud Shell instance, you run the Terraform init. If I run the Terraform init, you see that our Terraform is getting initialized, and here we are. So thereafter you run the Terraform plan. That's the next command. So the plan would show a high level overview of all the architecture that it's going to create and how it's going to create it. Then if we are comfortable with that, we can now approve. So these are sort of the things that is going to get created for us, and thereafter we can run the Terraform apply. So because we are creating a lot of resources, and I don't want to manually approve those resources, so I'm going to add an auto approve flag so that it just creates all these resources for me automatically. And yeah, you can see it's getting created. We'll wait for everything to get created. It may typically take a while. Fast forward it and see at the end. Okay, yeah, so everything has been created, and I'm going to take a look at it on my console. But before that, let's see if we've completed this first task. Now you can see most of we are complete. So if you want to take a look at it, you can go to your compute engine, go to your virtual machines, and see the 3 virtual machine instances that we have here. So these are the ones that are created before from the configuration that we want, the private test server and the public test server. And this is the one for the SQL client, this is the one for the SQL server Windows, and this is the Windows admin. And you can see that the SQL server does not have an external IP address because we are creating it in a private network that does not have an external IP address. And the SQL client is going to connect to this SQL server from this Windows admin. Yeah, so we are good. Let's keep going. The next thing we want to do is we want to administer our database server. So because we would need some information there, we typically want to maybe copy this somewhere. I'm going to copy it in my notes, and I'm going to put the password there as time goes on. So just paste it here and fill in the password as time goes on. So let's get started. Go to the Windows admin, then we want to set up our RDP connection, and before we can do that, we have to set our passwords and our username. So here we are. So to set up our RDP on the Windows admin, from the drop down menu, then we set our password. I typically want to keep this username, so I don't want to change it, but feel free to change your username. I'm just going to paste it here. Use from my Windows admin. Then when I press set, it's going to generate the password for me. Yeah, so here's my password. I copy it, then save it on my notes here so that when I need them I can have access to it. Yeah, so the same way we generated for our Windows admin, we'll do the same thing for our SQL Windows Server. I'm going to close this. This is our SQL Windows Server RDP here. Set the Windows password also. Then I'm going to copy this username. Just going to stick to this username. Here we are. Now I have to copy it in the username section. And for my password, when I click on set, it's going to generate my password for me. Yeah, so here's my password. I copy it and I paste my password in its position. I also have to copy the internal IP address of my SQL server because I'll need that. So under my internal IP address, I paste it there. Yeah, and yeah, that's typically it. So the next thing we want to do is we want to log into the RDP of the Windows admin machine. And to log into the RDP, we would go from the remote desktop. So on the Windows menu, so the first thing we want to do is from our Windows machine, this is the Windows machine, we click on RDP, and to connect to the RDP, it's more of like download the RDP file. So when we download the RDP file, then I have the remote desktop client, the app on my Mac that I can use to open this. For my connection, I can import from RDP file. So when I'm importing my connection from RDP file, this is the one that I just downloaded now. I'll import from that. After importing from that, I can decide to maybe edit something there and edit what's not necessary. So this PC name should not be this. So I'm going to copy my IP address of this one, of my Windows admin RDP. And to get the IP address, from here, sorry. To get the IP address of my Windows RDP, this is it here. Copy it. So this is what I'm supposed to use here. And now I can save it. So after saving, I can attempt to reconnect, and we should be able to connect. So I'm going to copy my password. This is my password here. Copy it, then paste it here, and show the password, and continue. Yes, hopefully it works now. Still not working. What's wrong? Windows admin, am I copying the wrong password? Oh, I'm supposed to copy this password with this semicolon. There's a semicolon here and I'm supposed to copy it with it. Sorry for that. So paste it here, show the password, make sure the semicolon is showing, which is part of my password. Yeah, so you can see that now we are able to connect, and we are connecting at the moment. So here we are, you can see. So while this is connecting, let me just go over the next instruction. So you can see that we are connecting to that. So while we are connecting to that, there's a remote desktop shortcut from here. Let's see. Yes. Okay. So let's see. Yes. Yeah. Let's wait for this guy to load, the server manager, then I'm going to cancel out on it, as I do not need it. Yeah, so I'm just going to cancel out on it. So from our startup menu is a remote desktop here. Then I'm going to use my connection here from the instruction here. So when I'm here, and log in with the username and password that you created. So the external IP address of my SQL server, that's what I'm supposed to use to connect. So here's my external, my internal IP rather of my SQL server. Internal IP, yes. So come here, input the internal IP and attempt to connect. So then I put my username and password, which should be the username, and password of my SQL server. So here we are. Copy this username, copy the password also, which is this here. You can see that you really need to have this information so you can show it. Then okay, and yes. So we are connecting, and now we are connecting to our SQL server to the Windows client that we created, and now we can make changes on our SQL server or just set up some configurations. So here we are. So now we want to go to the Microsoft SQL Server Management Studio and use it to configure our SQL Server user that we are going to use here. So I just need to connect here. Typically, I do not need this now. Yes. So let's wait for the server to load. I'm also going to cancel out of this as I don't need it. Just waiting for it to cancel out. Thereafter, from the start menu, I'll write this SSMS. So it should bring out this, should show this here, and I open this, and this is my SQL Server Management Studio. It's getting opened for me. Just going to wait a bit till it's opened, then do the necessary configurations that we want to do here. Yeah, so here is our SQL Server Management video. So this should take what we need already. So just connect to this directly. It's connecting, and yeah, here we are. So the next instruction is to set our SQL Server. We should set the security to the SQL Server and Windows authentication, and thereafter we'll now restart. So to do that, from here, my SQL Server on this, you can just right click on it, then you go to the properties. From the properties, under security, we'd set it to the authentication to the SQL Server and Windows authentication mode, then okay. So yeah, you can see some of your configuration changes will not take effect until SQL Server is restarted. So that means I have to restart it. So I'm going to restart here. I'm going to accept the restart. Yes. So you should stop and reconnect. Yeah, so we restarted our server, which is fine. If you do not see something like this, you can attempt to refresh and you should see it. Okay, so the next thing we want to do now, we've completed it here. So under the security and logins, we want to create a new logins, and for our SQL Server user, then enforce would clear out the enforce password policy and would use an SQL Server authentication. So under this here, from our security to logins, can expand the logins also. So under the logins, then you now do a double click on it, then link new login. That wants to use an SQL Server authentication. So you can use a username here. So I'll just stick to the username that I've been using, which is an extract of my ID. Then I'm going to use this one here. So using this one, I'm going to use the password. I'll use comments as my password, and use comments to confirm the password also. Then after that, I would clear out this enforced password policy as recommended by the lab. Then okay, so let me just save my password on here. My password is comments. Let's save it here, and this is this is my username. Just save it here also so I don't forget. Okay, we are good. So the next thing we want to do is, so we can take a recording of all these ones, and we can close the desktop session on the SQL Server, because we are typically done with all the configurations we want to do here. But I'll just leave it running. The next thing I want to do is I want to connect to the database from a client, which is the SQL client that I have. So on our SQL client virtual machine instance, I'm going to SSH into it and run this command. So this command installs the SQL Server client software, and it also helps us to test the login that we just created to see if it actually works. So from here, this is our SQL client with SSH into it. So I'm SSHing, is transferring the keys and establishing a secure SSH connection. Yeah, so from here, I run the command. It's doing the necessary things. Then I'm going to say yes here. And for all this, you also say yes. To say yes, you just need to use your arrow key on your computer, then enter your arrow key, then enter. And here we are. You can see all the necessary things here. Yeah, so this is it, which is typically what we want to do. So going back to the instruction, yeah, the next thing we want to do is also enter the following command. So the SQL client is in our path that we specified. So we'll just make sure we echo the path to follow all these paths that we want to use to test. So from here, echo it, and enter. So after we've done, we want to test our connection and see if we actually connected. You can check your data, check your progress here, and see that we've actually done this. So we want to use our machine IP address and the SQL Server username that we created, and we also enter the following command and the password when prompted. So what we did, we want to test our connection and see if we actually done something on our SSH instance. So I'll change this to the IP address of my SQL client, which is this one, of my SQL server rather, which is this 10.2.2.2. Copy it here, go to the SSH. So just change this one to 2, and I'm going to use my username, which is the username I used here. I'm going to copy my username. Yeah, so good. Oh, there's our SSH. So use the username here. Then enter. So to request for our password, I'm going to use my password, which is comments. And you can see that we are now inside. We've tested the connection and we've been able to access it. So the database at the moment is typically empty. It's typically empty now, but we just provisioned it. So now that we've been able to enter, you can see that at this point there's no database, so there's probably nothing we can do at the moment. But we've set up the solution of everything, and your database server is in a secure network with no public access. Then we now use the Windows machine in the public network that can be used to administer the database. And we also have a client machine that can access the database via the SQL Server port that we used. So the connection is typically simple and straightforward. Like I said, from our SQL Server, which is the database that we have, we created it in a private network. Then we now created a Windows admin in a public network, and we created the client, so the client will talk to the server through the Windows admin, which has a network. And this is typically the best way when you want to create that. So to exit the SQL CMD, you can press quit and then would be out of it. Then thereafter we can go back to our cloud shell and destroy everything that we've created, because we don't want to just keep them running. So just the Terraform apply command, then you change this apply to Terraform destroy. I would also use the auto approve because I don't want to manually approve them. So to destroy everything, and I'll just wait for it to destroy finish. Then when I run this, when I refresh this, you see that everything here would be gone. So this lab is quite complex a little bit. You can spend your time going over the instructions and see how well you can create an SQL Server database on Complete Engine. Let's see. So you can refresh along the line and see those that have been removed. So some of them would have been removed, and you can see some of them are also processing. So they are getting removed one by one, and as they get completed, immediately these instructions get completed, you see that everything here has been finally removed. Yeah, so if you really enjoyed this lab, make sure you smash the like button, comment your thoughts in your comment section. I want to see the comments you have about this lab, and also share with your loved ones, or share with those who are planning to migrate their SQL Server database to Google Cloud, or just to or typically any cloud, using the Complete Engine migration, which is typically like a lift and shift. Still destroying. I just want us to finish this so we can see for ourselves. You can keep refreshing, and you also notice that one by one it's deleting them. Yeah, so typically everything here has even gotten deleted, but there are still some VPCs that need to get deleted. So when we go to our VPC, to your VPCs that is here, because you cannot create a virtual machine without having a VPC, so this should also get deleted. When I refresh this private VPC should have gone, and you can see it's out already. So thanks guys for staying through to the end of this lab. So an higher level overview of what we did is that we provisioned an SQL Server machine in a private network, then we created a Windows machine in a public network that we can use to administer the database server. Then we also created a Linux client in a public network that was used to connect to the database. And we set up a firewall rule that allow access to the SQL Server database only from the private network. I hope you really enjoyed this lab. See you in the next series. Bye for now.